All right, hold on to your hats. We're going to get some really nasty chain rule problems. Now, calculus classes really vary in how hard they get, like how gnarly things will get. If you're in calculus for economics or business majors, or possibly like a regular high school class that's not AP, you might not have to do stuff this nasty. So just, if I start getting into crazy stuff, compare it to your homework, compare it to your class notes, see if you have to do anything this hard. Again, chain rules plug and chug, but it's just how many times do you have to do the chain rule in one problem? Is it like a chain rule of a chain rule of a chain rule? Now it's nasty. All right, so here's a double chain rule problem. Let's see what happens. Well, let's see. Right off the bat, I can see that there's a sign involved, so my temptation is to think that this is a sign rule. But really, this is a sign to the third power problem. So this is a power rule where my u is all this junk. My u is sine of 5x squared. So I would encourage you to do this when you're first starting out, just to not get confused. That 3 is kind of in the middle of things, so I'm just going to rewrite the problem as sine of 5x squared with that 3 outside, so it just looks more like a standard power rule problem. And now you can see really clearly that my u is just the sine, to the first power of 5x squared. All right, so let's take a look. What is my derivative? Well, power rule derivative is just the old power times the same u, which is sine of 5x squared. The new power is 1 less than the old power, so that 3 gets knocked down to a 2. Now I got to multiply it by u prime. All right, but the problem with u prime is that that's a chain rule of its own. I'm taking the derivative of sine, which is clearly cosine, and it's going to have the same argument thing, because whenever you take the derivative of a sine or cosine, then the thing afterwards, this little guy right here, is always the same. So that's cosine of 5x squared. But then I got to, since that 5x squared is not just an x, it's an x squared, or 5x squared, I got to take the derivative of this stuff. And that's my u prime for the little cosine here. So derivative of 5x squared is 10x. All right, so that is my nested chain rule example. Now I can go through and simplify things a little bit. Not a lot I can do, but this 10x and that 3 should probably be combined. So I'll get 30x out front. And then I'll get, this sine 5x squared, quantity squared. I could move this 2 into the more normal place people write it, which is right above the sine. So I'll just rewrite that as sine squared of 5x squared. And then I got my cosine of 5x squared as well. All right, actually wasn't too bad. We've done ones about that hard before. It was a nested chain rule, a double. So we had to use a chain rule initially to find the power rule derivative, but then when we found u prime, we had to take the derivative of this guy, which is its own little mini chain rule problem, and that's what ended up with this 10x. So the easiest way to have gotten this problem wrong would to have forgotten this 10x, sort of the u prime of the u prime, if you will. All right, product rule inside a power rule. I don't even know what that title means. It's so confusing. Let's see what happens. All right, so once again, I got a secant, which is kind of a weird one, to the 5th power. So what I should do first is just move that 5 to outside of a big set of parentheses to make it more obvious that it's a power rule. So I will have 2 times the secant of x times e to the x, all to the 5th power. All right, now as soon as I did that, I saw what's going on here. This is a hard one, because we got the secant of something that's multiplied together. I got an x times an e to the x. So I don't know when, but at some point in this problem, probably near the end, I'm going to be finding a u prime at some point, and it's going to have a product rule built in. So let's just feel our way through it. So that's just what's coming. Mental note, check the box. There's going to be a product rule in here somewhere. So if I get to the end of the problem and I have not used the product rule, I'm going to want to rethink it, backtrack, and see what I did wrong or where I forgot to do the product rule. So step by step, first thing we do is, since it's a big power rule, a bunch of junk raised to the 5th power, let's do the power rule. So I'm going to move that 5 out front, so I get 2 times 5 is 10, because that 2 just stays there. Then I got the same stuff, so secant of x e to the x raised to now the 4th power, because I have to take 1 away. Now I got to do a u prime on all this stuff. So this was my u. So now I got to find the u prime, the derivative of secant x e to the x. All right, so what's the derivative of secant? Well, for starters, it's secant of the same stuff, so x e to the x. And then it's also times tangent of x e to the x. But I'm taking a derivative of a secant of something nasty, which means I'm going to have a u prime on the end of this thing. So what's the derivative of x times e to the x? Uh-oh, that's the product rule I've been dreading. So I've got to go do the product rule on e to the x. So what is x e to the x? What's the derivative of that, or that thing prime? Well, it's going to be x e to the x. And then this time I'm going to keep the second one and take the derivative of the first one, which is just 1. Alright, so it's x e to the x plus e to the x. I can factor out an e to the x and I get e to the x times x plus 1. I don't know if you have to do that last step, but hey. Okay, so so what goes here is this little u prime from the first chain rule. So that's e to the x times x plus 1. Yuck. Alright, so now I've got a long string of stuff. And this is all my answer. So the only question is there anything that can be combined here to make things look better? Well, let's see. I've got a secant to the 4th power and a secant to the 1st power of that same stuff. So that looks, I can combine that. And I've also got a 2 times 5, which should be a 10. So I'll do the 2 times 5 is 10. Then my secant to the 4th power times secant to the 1st power is going to give me a secant to the 5th power. And then I've got an tangent of x e to the x. And then finally, I've got an e to the x times x plus 1. Oh my gosh, pretty crazy. All right. Whew. Exponential with a nested chain rule type situation. All right, so for starters, we got a sine of something, so that's not too bad. So this is our u, right? So the derivative of sine of anything is cosine of that same something. E to the x squared minus 3. All right, but then I got to multiply by my u prime. And my u prime, derivative of e to the x squared minus 3. Well, the derivative of e to the anything is e to that same thing. But then I got to multiply by the derivative of that exponent, which in this case is just 2x. All right, so if we want to simplify this, not a lot we can do. Maybe just put that 2x and the e out front. So I'll do 2x times e to the x squared minus 3. And remember, putting these dots in for multiplication, you're not going to lose any points for that, and it can help a lot with clarity. Cosine of e to the x squared minus 3. Boy, that one wasn't so bad, actually, because there's no product rule in there at least. Now, if you want to see some nasty chain rule problems with product rules, next chapter we're going to redo the product rule and the quotient rule, only with chain rule, because it's just pretty gnarly. All right, this one looks kind of bad. We have some roots in there, and of course the trick with roots is always to rewrite it as a fractional power. So we're going to write this as the derivative of sine 3x to 1/2 power plus sine of 3x to 1/2. And that's just going to make it more obvious that I can use the power rule on this thing either initially or as part of it. All right, so since we have the derivative of something added to something else, we're just going to get the derivative of this and the derivative of that totally separately. So the derivative of this first term, it's just a power rule, so it's going to be 1/2 times the same, it's a power rule, so we're just going to keep our u, so that's sine 3x. And now our new exponent is 1/2 minus 1, which is negative 1/2. And now, because it's the power rule and our u is something funky, we got to add our u prime on here. Derivative of sine of 3x is cosine of 3x, but then since that's a 3x, not an x, we got to multiply by its derivative. So like a mini chain rule, which is just 3. So the derivative of 3x is just 3. All right, so that's our first term. Then we're going to be adding, let's see, now this one is not a power rule. This is just a derivative of a sine is cosine. So cosine of that same thing, which is 3x to the 1/2. But then since it was a sine of something weird, I've now got to multiply by u prime, which is the derivative of this something weird. Derivative of 3x to the 1/2 is going to be 1/2 3x to the negative 1/2. So far so good, except that was actually a power rule because this is, this is a u, this is like a little u to the 1/2, which means I need a u prime for that. So the derivative of 3x is 3. Now this is getting confusing. That makes sense. You might not be doing problems this hard, as I said earlier. But if your class is, you've got to get used to just keeping track of how many u primes you've done so far. All right, so 3 times 1/2 is 3/2. And then I'll just rewrite this. Oops, that'll actually be downstairs. We'll just leave it. Times cosine of 3x plus, see, 1/2 times 3 is 3/2. Cosine of square root of 3x times, let's see, 3/2, already used that. Then we got 3x negative 1/2. All right, so right here we have a pretty big mess. You could leave this the way it is because we pretty much executed the problem, got it mostly right. Some teachers will want you to do this though. So that 9/2 will split into 9/2. Then this is a positive exponent, so we'll do cosine 3x. And then downstairs, we got to put, this thing is negative, so this will be the square root of sine of 3x. Then for the second term, we've got a negative exponent over here, this 3x to the negative 1/2, so 3/2. And then cosine upstairs. And downstairs, we've got the square root of 3x. All right, so pretty wild stuff. This thing didn't make any sense, looked like an abstract nightmare. Whereas this thing, I'm not saying you would have to do this, but if you wanted to do some algebra on this and combine, find the denominator, common denominator, all that kind of stuff, it's conceivable that you could actually do some algebra on this, right? Because now it's fractions, and we know how to deal with fractions, even though it is a pain in the keister. At this point, I would definitely walk away. This will get you full credit from any teacher I've ever seen. All right, last one. This is going to be a nightmare. I'm just going to point out right off the bat. We got a square root. We got a product rule because we have things times things. Oh man, this is crazy. But you know what? We're going to pile on through. All right, this is the last one I'm going to work in this video. There's actually a really nasty product problem, a product rule inside of a root. So it's kind of a chain rule problem, but it's also kind of a product rule problem. So if you want to stick around, but this is really hard. This is like as hard as any derivative problem you'll ever see. So unless you have the worst AP teacher in the world at a really hard school, you're probably going to be okay if you skip this one. All right, so away we go for all you diehards. First of all, you want to realize, you know what? Now that I see this one, I know I made up this problem, but this is worse than anything you'll ever see. So I'm going to walk away at this point. As you can see, I was about to do the chain rule on this thing, which is like, negative 4x. And I still had another like this much stuff to do. So if you're watching these videos, you're probably never going to see a problem this hard. Let's hang it up.